Hi, in this lesson, we'll look at developing algorithms using array lists. In the last lesson, we learned how we could remove a specific element from an array list. Using a for loop, we could traverse a string array list and figure out which values in the array list started with the letter A. We can alter this method so as to remove specific elements from an array list, not just those that start with the letter A. For an array list of strings, we can do so by using list.getI.equals_element, which checks if the individual values in an array list match the value of the element in question. Traversing an array list to remove specific elements is a standard algorithm for array lists. There are other standard array list algorithms that utilize traversals that you should know as you continue to work with array lists and as you prepare for the exam. One standard algorithm that we need to cover is how we can add an element to an array list while traversing. Here is a general formula for how we can do that. Let's take a look at an example using this algorithm. Suppose we wanted to traverse an array list of integers. Let's create a method that adds an element to the array after all of the odd index values. If any of the values were odd, we will add that number plus 2 as a new value at the index following the value. For example, if index 0 were value 3, we would add the value 5 to the array as a new element and place it at index 1. Using the standard algorithm for inserting an element, we can create this method with a couple of small adjustments. First, the if statement in this method is testing to see if the value at the index is even or odd. If the value is odd, then the if statement will evaluate to true and execute the code within the if statement. If the if statement executes, the first command adds the value plus 2 at the index plus 1. If the current index is 0, then we would want to place the new element at the first index. Hence, the list.add command adds the value at index plus 1. Because the new value is being added at index 1, we don't want to include it when we are iterating through the array list. We add index plus plus so that the value that has just been added is skipped. Let's take a look at this in action. The for loop variable index is initialized to the value 0, and the for loop begins. The value of lem is assigned the value of the first index 0. Because lem is odd, the if statement returns true and is then executed. Because the element is odd, we add the new element, 3 plus 2, to the index following the current index. Now at index 1, the value 5 has been inserted, and the other values are shifted up an index in the array list. Next, we add 1 to the value of index. Now when the loop iterates again, the value of index is increased again, making the value 2. As a result, this skips evaluating the newly added value of 5 and continues evaluating the array list indices that were originally in the array list. If we were to remove the index plus plus command in our code, we would run into a serious bug. After adding the value 5 to the array list, the value of index would be increased to 1. Now the value of lm would be 5, the value that was just added to the array list. 5 is odd, so it will return true, and the if statement will execute. Now the value 7 will be added at the next index. The problem with this method is that the next value in the array list will always be odd, as the newly added value will be an odd value. This means that this array list will grow infinitely and never evaluate the other values that were originally in the array list. Without the index plus plus command in the if statement, this program will cause a crash. Because the array list grows infinitely, the program runs out of memory trying to store the values in the array list before the program ever executes. Just like arrays, array lists have a series of standard algorithms that can be used to traverse their values. You need to be familiar with these algorithms for the AP exam. We can traverse through mathematical computations by initializing a value outside of the traversal loop and then perform calculations within the loop to determine a min or max value, or complete a sum, average, or mode. If we want to determine if elements have a particular property, we can initialize a tracker value before the traversal, and then conditionally check for that tracker while traversing the array. We recently used this general formula when finding elements that start with the letter A and removing them from our array list. If we want to make alterations to the list by reversing the order or shifting the elements, the general format requires that we create a new array list that will then hold the values in the order we would like to rearrange them. Each iteration through the initial array will add a value from the initial array to the altered array. Some standard algorithms also require arrays and array lists to be traversed simultaneously. For example, if we wanted to sum the indices of two array lists, we could do so by traversing both of the array lists at the same time. Let's take a look at how we could do that. First, let's start by creating a SumArrays method declaration that takes the inputs list1 and list2, which represent two array lists of integers. Before moving on, can you figure out what steps we would need to take in order to implement this method? Here are all the steps that it would take to implement this SumArrays method. First, we would need to initialize a new array list. This is the list that will be returned from SumArrays with all of the updated values based on the sum. Next, we need to create a traversal that will allow us to go through the values in the array lists. Since the two array lists are the same size, we can just choose one of their sizes and set the traversal to end at the last index of that list. Next, we can add the two values at the same index from both array lists together into a summed value. Even though we've created one traversal, we are traversing through two array lists at the same time, grabbing the index in the same location and assigning it to the value sum. Next, we can add the sum value to the summed list, which will put the sum of both array lists in the same index location in the summed list. Lastly, we can return the summed list, which will have the summed value of list1 and list2 at each index. It's important to note that this will only work correctly if the array lists are the same length. When traversing array lists, you must pay attention to the size of the array lists to make sure that traversing won't lead to errors. Now that you've learned more about developing algorithms using array lists, let's get some practice using them in the editor.